Okay, this is the first of our videos on reduction formula, and to be quite honest, this first video we're really going to be just recapping integration by parts and one-step process reduction one, so it's not really massively a reduction formula. So if you're really looking at one where it's a formula for reduction formula required, you need to look at the next video, so just skip on to it now, please. Okay, right, first of all, just a wee recap of your integration by parts. The integration by parts formula is the integral of u upon dv by dx integrated with respect to x is uv minus v du by dx integrated with respect to x. So the general rule for these, what you typically do, not always as we'll see in our third example here, is you make your u something such that du by dx is a simpler function. So for example here, you would make your u be equal to your x such that du by dxn is equal to just 1. And your dv by dx is e to the xn, and if you integrate e to the x, you just get e to the x. So if we do this then, if the integral of x upon e to the x integrated is going to be just our uv, so it's going to be x times e to the x minus the integral of my v times du, so that's just e to the x times 1, that's integrated with respect to x. So if you do that, that's going to be x e to the x minus, and then integrate e to the x, you just get e to the x, and remember plus c, your constant of integration. Very similar in the next question as well. So this one, we've got to find the integral of x cos x. So again, let your u be equal to the x, because if you differentiate it, you just get 1, a very simple function, and your v is equal to cos x. If you integrate cos x, you will just get sin x. That means the integral of x cos x, remember uv, so x times sin x, minus the integral of v du, so it's minus the integral of just sin x, and then that is just x sin x, and if you integrate sin, you get minus cos, so I'll just put that in just to, well, that's where people make very silly mistakes, and then plus your constant of integration, and then to avoid that silly mistake, then you can see it's a minus times a minus, which is a plus, so plus cos x, and then plus c. Okay, next example says integrate ln of x. It is worth your while learning this. So if you get one like this, or even maybe something like x squared times ln of x, you would think that you would make your u be equal to just the x squared, but in this case, make your u equal to your ln, and then your dv by dx equal to x squared. So that's what you always do. So learn this one. This is a very special one. So same idea in this one. We are going to let our u be equal to ln of x and our dv by dx be equal to 1. So if you differentiate ln of x, you'll get 1 over x. If you integrate 1, you will get x. So then it becomes uv, remember, so x times ln of x minus the integral of v du. So that's just going to be, let's just show all the steps here. V times du, so x times 1 over x, and sort that out, that's x ln x minus the integral of 1 dx, which is x ln of x minus x plus c, and there we have it. That's that one done. A very special one, worth learning. Okay, now we're going on to slightly trickier ones. So this one we've got to integrate x squared upon e to the x. So again, your u would be equal to x squared, du by dx would be 2x, your dv by dx would be e to the 2x, and if you integrate that, remember this wee thing here, if you integrate e to the mx dx, you get 1 over m e to the mx, and then plus c. So here, that's going to be a half e to the 2x. So fire that in, therefore your integral of x squared e to the 2x, uv, first of all, it's going to be a half times my x, x squared. I'm just going to write that as x squared over 2, and then times e to the 2x, that's my uv. Then minus my integral, and it's going to be a half times my, sorry, what am I doing here? My v du by dx, so it's going to be a half e to the 2x times 2x, which is just going to be x e to the 2x dx. Now, we are making progress. Notice I've called this equation 1. We now have to integrate this thing, but we can integrate this by parts again. But look, we're definitely making progress. This bit in yellow is simpler than the original integral. So we're going somewhere, we're going in the right direction anyway. So it's definitely simpler, so we're on the right track. So we're going to look just at this thing, and we're going to how we integrate this thing, and then we're going to come back to the original equation, equation. So here on this one, if we consider the integral of x upon e to the 2x, your u is just going to be equal to x, so du by dx is going to be 1. Your dv by dx is e to the 2x, so your v is going to be 1 over 2 e to the 2x. Okay, and then fire that in. That means this thing will become uv, which is just going to be x over 2 e to the 2x, and then minus the integral of v du, so it's going to be a half times the integral of e to the 2x, and then we'll sort that out. That's going to be x over 2 e to the 2x, and that will be minus 1/4 e to the 2x, and then plus your c. Okay, so we sub that back into equation 1. There was your equation 1 up above. So if we sub that back in, we now know that this whole bit can be written as this. So this is what's going into your bracket, and you're going to leave the c outside at the end. So we sub it back in, you're still going to have the x squared over 2 times e to the 2x, then minus, it's going to be x over 2 e to the 2x, minus 1/4 e to the 2x, and then plus your c at the end. If we sort that out, that's going to be minus x over 2 e to the 2x, and then plus 1/4. That's again very easy mistake, which very good mathematicians will make, and you can see that's as far as we've got. Okay, you could maybe pull an e to the 2x outside a bracket here. I wouldn't bother. I think that's fine, unless it's a show that question. Show that the answer is e to the 2x upon whatever it's going to be, or maybe it's going to be 1/4 e to the 2x. That's probably more likely what they would do. But unless you have to, you're going to get the marks for this. Okay, next one. We've got 2 more to go here, I think. So in the next one here, we've got e to the x and sine x. Now, it's sort of, I think you could do this one either way. I think you could let your u be equal to e to the 2x or your sine x. So we'll just go with the way I've done it here in my notes. But I think you could try it the other way. Try it yourself and see if it works. Why not? I don't think there's any benefit in picking a particular one. But that's what you get. If you let your u equal sine x, that means your dv by dx is e to the x, and also your du by dx is cos, and your v is e to the x. So, that means uv then is going to be, and I'll just write e to the x first, times sine x. So that was your uv, then minus the integral, and then it is v du, so it's going to be e to the x cos x dx, and that you can see is my equation 1. Now what we've got here, we haven't actually got a simpler function. This integral here is just as complicated, or certainly no more complicated than this one, but we're just going to persevere with this and see what happens. We're going to consider the integral of e to the cos x and do it the same way as you've just done. So let the u be the trig function, and if you differentiate that, then you'll get minus sine of x, and your dv is equal to the e to the x, and if you integrate that, you'll get e to the x. So if you look at that, then your uv is going to be e to the x cos x, and then minus, and that's the integral of minus then e to the x sine x dx, and I'll just write that again. That's e to the x cos x, then it will be minus minus is plus, e to the x sine x dx. Okay, right, now this is what we're sort of getting to our reduction formula type questions then. You can see this thing, e to the x sine x dx, that was your original I way back at the start. So we really could write this whole thing as that means, therefore, your integral that you're trying to find is equal to e to the x cos x plus the integral, that's not right. Apologies. Let's sub that back in properly. We'll put it back into the equation 1. So this is putting it back into equation 1. Your I is equal to, it was e to the x sine x, then minus, and our whole yellow thing here became this. So it was minus, use a bracket, e to the x cos x, then plus, that's that integral, and that was our I then, and then plus c. So there's where we've got to. So you've got all of this, tidy it up, that's going to be I is equal to e to the x sine x, then minus e to the x cos x, and then that's going to be minus I, and then plus c. Bring that minus I across, it will become plus I, so you've actually got 2I is equal to e to the x sine x minus e to the x cos x, and then plus c. And then your last line, that means your I can just be equal to a half times that e to the x sine x minus e to the x cos x, and then plus c. And then that means that you could write that as e to the x over 2 times just sine x minus cos x, and plus your constant of integration. Okay, lovely. So a wee bit of a trick to it. We're going to look at one more here with a definite integral. Definite integral, remember, just means limits. So this is what we have to integrate. I would let my u be equal to my x, so my du is just 1, and my dv by dx is x minus 1 cubed. So sort of thing you would maybe forget, this was from your regular A-level maths, you would have done this. So how you do this is you raise your power by 1 and differentiate and see what you get. So this is integration by inspection, really. So you differentiate x minus 1 to the power 4, you'd get 4 times x minus 1 cubed. Not quite what we wanted. So if you differentiate it a quarter times x minus 1 to the power 4, you'll get x minus 1 cubed. That means if you integrate this thing, I will get this. So that means if I integrate x minus 1 cubed, I will get 1 quarter upon x minus 1 to the power of 4. Okay, my integral then becomes, and notice I've used square brackets here and I've got limits. So this is my uv, so x over 4 times x minus 1 to the power 4. And then that's my v du, that's just going to be a quarter times x minus 1 to the power 4. And then we have to integrate that bit still. Now, first thing we have to do here, notice I've said here, generally saves time to sub in the limits. If you put your limits into this, put 1 into it. In this bracket here, if you put 1 into that, 1 minus 1 is 0. And then you put 0 in, so the first limit, when you put in the 1, it's going to be 0 overall, 0 times anything, 0. And also put the 0 in, 0 over 4 is 0. So that whole bracket just becomes 0. So it's 0 minus 0, so I'll just do square bracket 0 minus 0, just to show all my steps here. But definitely you save a load of time if you put the limits in for that bit, because quite often it's 0, or maybe it's like pi over 2 or whatever, but whatever it is, it's a heck of a lot easier than having to write out square bracket x over 4 upon x minus 1 all to the power 4. So it saves you a load of time. Okay, this thing, we want to integrate this, so I'm going to do this by inspection. So I'm going to raise the power by 1 and differentiate to see what I would get. If I did that, if I did that out, sorry, what would I get? I would get 5 over 4 times x minus 1 to the power of 4. So that's not quite what I want. So I'll multiply that by a fifth, so it's going to be that. And see what I get. Differentiate that. I will get 1 over 20 times 5, which is going to be, 1 over 4 times x minus 1 to the power 4. So you can see if I integrate this thing, I will get square bracket. I forgot what I've got. What I get? 1 over 20 x minus 1 to the power of 5. And that's between 1 and 0. So we'll go back to here. So that was just minus of that. We can forget about that. 0 minus 0 is just 0. Minus of then, and we'll show our steps. 1 over 20, and then put in the 1. Put in the 1. That's going to be, here's this whole thing going to be 0 just? No, it's not. 1 minus 1, that is going to be 0 for that one. 0 to the power of 5. Then minus 1 over 20, and then times, put in the the 0, you're going to have just minus 1 to the power of 5. And then sort that out. That's just going to be minus square bracket of 0. And then that would be minus, and that would be minus 1 over 20, which is going to be just minus 1 over 20 as my final answer. And that's it. Done.